scientists have released a video showing how dangerous the asteroid 2024-yr4 could be if it hits a city. Experts are worried because there isn't much time to prepare for its impact. NASA and other space agencies are considering extreme measures, like using nuclear weapons to stop it. In addition, recent observations from the James Webb Telescope have also increased their concerns. In today's video, we'll take a closer look at this asteroid, how it could impact Earth, which areas are most at risk, and what space agencies are doing to prevent this disaster.
NASA has impacted other asteroids to see the effect on their orbit and their trajectory, and that has worked to a limited extent. But it might not work for this object. It may well be. We might even have to consider the severe measures of sending up a nuclear weapon to the surface of this asteroid in order to deflect it further.
In early 2024, astronomers made a significant discovery when they detected a near-Earth asteroid designated 2024-yr4. Spotted by the Panoramic Survey Telescope and Rapid Response System in Hawaii, this celestial object immediately grabbed the attention of scientists worldwide. Estimates suggested that 2024-yr4 is an asteroid between 40 and 90 meters in diameter, a size large enough to cause serious regional damage if it were ever to collide with Earth. Although it might sound small compared to some of the giant asteroids known to roam our solar system, an object of this magnitude has the potential to unleash catastrophic effects upon impact. For example, NASA's calculations suggest it may be about 54 meters across, a size similar to the object that is thought to have caused the Tunguska event in Siberia over a century ago. The Tunguska event of 1908 remains one of the most dramatic natural explosions ever witnessed on Earth. The Tunguska asteroid exploded in the atmosphere over remote Siberia and was similar in size to this recently discovered asteroid. Although it never struck the ground directly, the air burst released energy equivalent to several megatons of TNT. The explosion flattened an estimated 2,150 square kilometers of forest, knocking down millions of trees and generating shock waves that shattered windows hundreds of kilometers away. While the sparsely populated region of Siberia spared human life from large-scale tragedy, the energy released in the airburst was enough to flatten forests over a vast area, and although there were only a few casualties due to the remote location, the same event over a modern city would have led to enormous loss of life and property.
There was an object which struck Siberia in 1908, which, had it encountered the Earth a few hours earlier, could have devastated London. These things happen every few thousand years, every few hundred years. Now, luckily, most of Earth is empty space. Most of the Earth is empty space, and that's getting increasingly less these days as we populate the planet.
But wait. The discovery of 2024-yr4 is not just another entry in the growing catalog of near-Earth objects. It has become a subject of intense study because of its unpredictable orbit. Initially, when the asteroid was first observed, scientists calculated its probability of hitting Earth to be about 1.3%, and its path will cross our orbit on 22nd December 2032, and was initially estimated to have a 1 in 83 chance of a direct hit. However, as more detailed observations have been made and its trajectory has been refined, the estimated risk has increased to 2.3%. Adding to the concern, further research by other groups has suggested even more alarming odds, up to 1 chance in 49. These changing numbers have not only raised the level of concern among astronomers, but have also prompted an urgent reassessment of our planet's readiness to deal with potential asteroid impacts. Although these numbers might seem small at first glance, even a few % chance of impact is taken very seriously by the scientific community, because the consequences of a collision could be catastrophic for a local region. With all this, an important question now arises here is that, Which part of the Earth is most likely to be impacted by this asteroid? Well, one of the biggest challenges in predicting an impact is determining exactly where on Earth such a collision might occur. At this stage, scientists use the term risk corridor to describe a broad band along the asteroid's projected path. For 2024-yr4, the potential impact zone is not fixed to one precise location, but could include a wide range of areas. Current models suggest that if the asteroid were to hit, its impact might fall somewhere along a corridor that stretches over parts of the eastern Pacific Ocean, northern South America, portions of the Atlantic Ocean, areas of Africa, the Arabian Sea, and regions in South Asia. This uncertainty is due to the inherent challenges of calculating an object's orbit when it is still relatively far from Earth. As additional observations are made over time, scientists expect that this uncertainty will shrink, eventually revealing whether the asteroid is on a collision course or will safely miss our planet. Because of the rising risk estimates, the scientific community and space agencies are now intensifying their monitoring efforts. Telescopes on the ground and in space are tracking its movement, and international collaborations are refining its orbital parameters in real time. On the other hand, recent reports indicate that some scientists are planning to explore a nuclear deflection strategy as a last resort measure. Although such a plan might evoke images straight out of the 1998 film Armageddon, the actual execution would be far more sophisticated and fraught with technical, legal, and political challenges. The basic concept is not to shatter the asteroid into dangerous fragments, but rather to alter its course by transferring momentum. In practice, this would involve launching a robotic spacecraft armed with a nuclear explosive device. The spacecraft would travel toward the asteroid with precise navigation and timing. Rather than colliding directly with the asteroid, the nuclear device would be detonated at a calculated distance from its surface. The explosion would vaporize a portion of the asteroid's surface, a process known as ablation, and create a jet of ejected material. The resulting recoil effect, similar to the thrust produced by a rocket engine, would nudge the asteroid slightly, altering its trajectory enough so that it would miss Earth. Scientists are thinking about this bold step because recently, NASA conducted a hypothetical exercise to protect the Earth from a hypothetical asteroid that had a 72% chance of hitting the Earth in the next 14 years. During this exercise, scientists found that our current technology is not capable enough to prevent the impact of any such devastating asteroid in this time period. So if an asteroid actually poses a threat to the Earth in the near future, we have no solid defense against it. The Space Mission Planning Advisory Group, which is chaired by the ESA, recently confirmed in a statement that they will discuss the latest observations of the asteroid at a meeting in Vienna next week. If the impact risk is confirmed, it will make official recommendations to the United Nations, and work may begin on options for a spacecraft-based response to the potential hazard.